Okay, so let's start. Today will be a makeup class of Thursday's class. Okay, so we couldn't have a class last Thursday, so that's why I decided not to have a Q&A class like we have been having for the past 2 weeks, I guess. So instead, what we're going to do is we're just going to continue trigonometry. Okay. Walaikum salam. All right, so we now that we've had a taste of everything except for identities. Okay, we've if you guys remember, I said that we're going to do trigonometry in a circular fashion. First we're going to do equations, then we are going to do, I mean, not necessarily in that order, but I said graphs, equations, and identities. Okay, so what we're going to do today is we're going to do some more of trigonometric equations. All right, and but this time we're going to do some more complex ones. Okay, so a lot of times trigonometric equations become like a pain point of students. So it's easy to understand graphs, it's easy to understand identities. Identities, I think, is the easiest part of trigonometry, but it's the trigonometric equations that usually students struggle with. Okay, so what I'm going to do right now, I'm going to do the range. We call this range altering type questions. You might have done them in school already. Khair, not like I'm counting on it, but just so you guys know what we're doing. So yeah, okay, so let's start. I've taken out some examples. What's the date today? 25th. So briefly, can anyone summarize like how do we solve trigonometric equations in simple terms? You don't have to use fancy terms, okay? But in simple terms, like how do we solve trigonometric equations?
So firstly, we have to determine the quadrant in which we'll be working. After that, get the base angle, or else you say the alpha angle,
ठीक है.
horizontal axis, and then you can and then going, I guess, anti-clockwise, you can subtract that basic angle from the coordinate angle, and you'll get your answer.
ठीक है, सही है, sounds good. Okay, so we're doing, like I said, we're doing some complex trigonometric equations. Okay, but one thing we always watch out for is the range. Okay, as you remember, I said earlier that trigonometric equations are the only type of equations where you'll have a certain range. With other type of equations, exponential, quadratic, you're not necessarily given a range. Okay, so let's say that we have something that looks like this: sine x is equals to 0.5. Just make sure that you guys reset your calculator, bring it back in degree mode, unless I write a question which is in radian mode. Okay, and the range that you're given is from, let's say it's from 0 to 720 degrees. Now, can anyone tell me immediately what's the difference in this question? Like, what's the one thing that stands out in this question that we haven't done earlier? 720. Yes, good job. So 720 kind of stands out here. Okay, so let's see how we deal with that. Okay, now that our range is slightly extended, let's see how we deal with that. Now, at the back of our mind, we need to find trig function and take the inverse to find out alpha. ठीक है, सही है. Yeah, that's perfectly summarized. So at the back of our mind, remember what we're trying to do is we're trying to see when the graph of sine x is equal to 0.5 from 0 to 720 degrees. Okay, that's what we're trying to do in essence. So first things first, what quadrant are we in? We are in the first and the second quadrant. Why? Because it's positive. Okay, so I might change the order of steps a little. Okay, but the main steps remain the same. Okay, you determine the quadrant, you find alpha, and then you go on and find out the value of x or theta, whatever it is that you're asked to. So when you find out alpha, you can find out alpha by taking the sine inverse of 0.5. So it's already positive, you don't have to worry about it. So when you do that, sine inverse of 0.5, we get 30 degrees. Okay, so since it's positive, like I said, that means it's in the first or the second quadrant. Okay, so here's 0, here's 90, here's 180, here's 270, and here is 360 degrees. So here's 30, and here's also 30. So what is this angle going to be? This angle is going to be 30 degrees. There you go. And what's this angle going to be? This angle is going to be 180 minus 30, which means 150 degrees. Okay, so we have our two answers. Now, is that it? Question for you guys. Is that it? Can we say that's the end of the question? No, why not? Why is this not the end of the question? Okay, you're right. No is the correct answer. Add 360 to the first two values. That is correct. Acha, wait, why are we taking first and second quadrant only? Because sign is positive. Where do you sign positive? Sign is positive in the first and the second quadrant. Okay? So sign is positive in the first and the second quadrant. That's why we're only taking the first two quadrants. Okay? All right. So most of you said that this is not the correct answer. And the reason behind is that the range allows us to not stop at 360. The range allows us to go beyond 360. In fact, the range allows us to go 2 cycles. Okay? So how am I going to find out the other values? How am I going to find out the other two values? 2 or yes. Okay. Why? Because the range allows us to go a full circle and then another 30 degrees. Why? A full circle means 360 degrees, and then another 30 degrees means 360 plus 30. Okay. And then our same range allows us to go a full circle and then add 150 degrees. So the way that I like to do questions like these is this. I like to make separate quadrants. Okay. Now, in the first set of quadrants, we were starting from 0. Okay. In this quadrant, since we've already gone a full cycle, and now this quadrant is basically the story after the first cycle, that means this quadrant will start from 360, and I'll give you a shorter way as well. Okay, I'll give you a shorter way as well. So don't immediately freak out. I'll give you a shorter way as well. What I want you guys to, as always, understand the concept and stick to the shortcut. Okay. So now this is still the first quadrant. Okay, this is still the second quadrant. Sign is still positive. Everything else remains the same. AS, TC. Don't forget that. 30, 30. So in the second cycle, what we're doing is we're starting from 360 and then going another 30 degrees. So what is that? That is 360 plus 30, which is 390 degrees. And then what about this angle? 360 plus 150. Very good. Okay, 360 plus 150, which is equal to 510. Thank you. Okay, now before you ask me any questions, just wait a minute. Let me explain you guys one more thing, and then I'll take your questions. Okay, and we'll do more examples as well. So, yeah, here we go. So what I want you guys to look at is why we're adding 360. Because if you remember, I said that trigonometric curves are the only curves that are repetitive in nature. Okay, after a certain while, the same thing starts repeating. Okay, we can't say that about quadratic curves. We can't say that about cubic curves, exponential curves, no other curve basically except for trigonometric curves. So since they repeat, that means, and they don't just repeat randomly. Okay, they don't just repeat randomly. There is a certain pattern that we follow. Okay, y equals to 0.5. Okay, we'll get to that. We'll get to how it was done in your school. Okay, and yes, there are multiple ways of doing it. Okay, if that is a method that made more sense to you, you can stick to that. I have no issues. Okay, but this is the way that I like to do it. All right, here we go. So basically, we're focusing on 0.5. All right, so when is the graph equal to 0.5? Once it's equal to 30, and then it's also equal to 0.5 at 150, and then it's equal to 0.5 in the next cycle at 390. So what's the relationship between 390 and 30? 390 is 360 degrees more than 30 degrees. And then you have 510. So what's the relationship between 150 and 510? And that is 510 is 360 degrees more than 150. And the same pattern continues. Okay, we don't stop here. The same pattern continues, but the thing is, we're not going to give any more solutions. And why is that? That's because our range only allowed us to go till 720. So this, even though it's very close to our range, but it's still outside. All right, so the main thing that I want you guys to understand is that the same value we get after 360 degrees. Okay, in the next cycle, we get the same value after 360 degrees. Okay. All right, now let's have your questions. And I'm curious to know what method you did this, what method you did in school, Faiz. Just out of curiosity. The same one? The line one? Oh, okay. Okay. You mean using the graph? Okay. Yeah. So it's the same thing. Okay. We look at graph to further enhance our understanding. That's the main reason. All right. What else? Any other questions? Because first you used ASTC. So yeah, we will obviously have to use ASTC because we will not have the accurate graph in front of us, and we'll not always have values like 0.5 where the inverse gives us an integer value. Okay. All right, let's do another question. Let's say you have cos x, which is equal to minus under root 2 upon 2, and this time the range is from minus 360 to 0. Okay, so the range is from minus 360 to 0. Okay. All right, now quick question. When x is negative, what do we do? When the angle is negative, theta or x, what is the one thing we do differently?
Anti-clockwise?
The other way around. Clockwise. Normally we go anti-clockwise, but when it's negative, we go clockwise. Okay, so I know it's counterintuitive. Normally you would think that clockwise should be positive and anti-clockwise should be negative, but that's not how it is. When it's negative, you actually go clockwise. Okay, so this is anti-clockwise. The way that we're going over here is anti-clockwise. Okay. Acha, reverse cycle. Yes. So there are different ways to put it. So here's what we're going to do. First of all, no matter what you do, two things you will have to do, but our inverse will be of positive value. Yeah, alpha will always be positive. Okay, alpha will always be positive. So I was just getting to that. Two things that you will always have to do is, first you'll have to determine the quadrant where all this is taking place, and the other thing you'll have to do is you'll have to determine alpha. Okay, so normally the situation would be such that this would be 0, this would be 90, 180, 270, 360. Okay, but because the range of x is negative, this will be 0, but this will be 90, this will be minus 90, minus 180, minus 270, minus 360. Okay, remember what I said earlier. So here's 0, here's minus 90, here's minus 180, here's minus 270, and here is minus 360. Okay, A, S, T, C. Next thing you want to do is you want to find out alpha. How do we do that? Alpha can be found by simply taking, not sine inverse, of course, cos inverse of under root 2 upon 2. Okay, please remember, I don't want you guys asking me the same question again and again, that if y is alpha positive. Okay, because I've answered this question plenty of times, so it's better if you just work on your understanding and make sure that you remember it as well. So alpha is equals to 45 degrees. Okay, so alpha is 45, cos is negative. So we have this in the second and the third quadrant. By the way, does ASTC apply for clockwise rotation? What do you mean by that? Clockwise rotation? No, we No, wait a minute. Can you elaborate what you mean by clockwise rotation? What are we rotating here exactly? Okay, let him elaborate, Ubaidullah. Let him elaborate. I mean, when we are moving clockwise, okay. You mean, does the order of ASTC change? Is that what you mean? Mm-hmm. Sine is positive in the second. No. Okay, so, all right, I get what you're saying. So, the order of ASTC remains the same. This is still the first quadrant, this is still the second quadrant, this is still the third quadrant, and this is still the fourth quadrant. Okay, nothing happens to ASTC. All right. Okay. So here we have 45 degrees, and here we have 45 degrees. So I think somebody's already shared the answer. So basically, we are starting from the positive horizontal, positive x-axis, but this time, because of the range, we're going in an anti-clockwise, in a clockwise direction. Okay, made that mistake again. So we're going in a clockwise direction because normally you would think that clockwise should be positive and um, what do you say? Anti-clockwise should be negative. Okay, hold on to your questions, and I would please appreciate if you guys let me answer the questions. Okay, um, uh, I don't want everyone to get confused. Just let me answer your questions. Okay. Okay, so this angle would be, since we have measured this in a clockwise direction, theoretically it will be 180 minus 45, but because, like I said, we measured it in a clockwise direction, it's going to be minus 135. And then, what about the angle right after? This will be 180 plus 45, okay, in value, but because we've done it in a clockwise direction, this will be minus 225. Okay, I don't want you guys to start making a big deal of the minus sign or immediately. Just first calculate the angle like you would calculate any other angle, as if you were doing a bearing question or any other angle question, and then see what direction you've measured it in. If it's in a clockwise direction, write it with the minus sign. If it's if it's in an anti-clockwise direction, just let it be. Okay, let me answer your questions now. I vaguely remember, but to confirm, it will always be inverse of the positive value. Yes. So when you're calculating alpha, you always take inverse of the positive value. Acha, here if we cos inverse root 2 over 2, the answer is positive. So why do we exclude the minus sign? So the thing is, there's no consistency. Okay, there's no consistency. In some cases, yes, the answer will be positive. In some cases, it won't be positive. So we make a standard rule, and that is we just take the inverse of the positive value. Because if you do the same thing with sine, you will get a different answer. Okay. What other question? Is there any other question? Just putting, ठीक है. All right. Let me do one more example. ठीक है. Let's say that you have the following. Tan x. Achha, by the way, let's examine this using a graph also. ठीक है. So here we're gonna make cos x. We're gonna change this to cos x. Let's change the range slightly. Yeah, go ahead. Okay, so here also I want you guys to pick up a pattern. Okay, let's do it together. So we have to do 180 minus 45, 180 plus 45, and then we put the minus sign. Yeah. Because you've measured in a clockwise direction, so your final answer will be negative. Okay. The way that you're going to measure the angle is the same like you would measure any other angle, but in the final answer, just write minus because you've done it in a clockwise direction. Okay, so here are two values. Let me highlight them again, 135 and 225. But these values were not included. I mean, these values we can't have as our answer because they're not included in the range. Our range was from minus 360 to 0. Okay, so let me highlight them once again. 135 and 225. Okay, now what about minus 135? How is minus 135 related to 225? And how is minus 225 related to 135? Okay. Acha, Faiz, I would really appreciate if you focus on what we're doing right now. Okay, let's not jump from one thing to another. Okay. So 225 and minus 135, how are they related? Question for you guys. And 135 and minus 135. Sorry, 135 and minus 225, how are they related? Question for you guys. Try and observe a pattern and come up with an answer. Yes, 360 difference. That is correct. Okay. So 360 degree difference. So basically, 135 is minus 135. Here it is. Sorry, I keep minus 135. Here it is 360 less than 225, and minus 225 is 360 degrees less than positive 135. Okay. Why is that? Why is there a difference? Because 135 and 225, if you think about it, are the values in the first cycle. What we want are basically the values before that cycle. Okay, so how do you go from one cycle to the next? You add 360. How do you come from one cycle to the cycle before that? You subtract 360. Is everyone getting my point? The main emphasis here is on adding 360 and subtracting 360. If you want to find out what the value is in the next cycle, you add 360. And if you want to find out what the value is in the cycle before that, you subtract 360. Okay. Did I miss a question? Another question. Cos inverse minus 2 under root 2. So why take the second or the third quadrant? Okay. Now, remember, that's a good question. So you've said that cos inverse of minus under root 2 upon 2 is a positive value. Okay. So why take the second or the third quadrant? So the thing is, the angle is positive, but cos of that angle is negative. So when we say ASTC, Arij, this is the answer to your question. What we are saying is that if you plug in any angle that is, let's say, from the range of that is in the second quadrant, cos turns out to be negative. Okay, so this minus sign is not for the angle. This minus sign is of the cos value of that angle. Okay, so what you're getting 135 means that if you find out cos 135, you get a negative result. So it depends on the value. It depends on what the end value is. So if the end value is negative, that means it's going to be either in the second or the third quadrant. We're talking about cos here. Okay, so why will we take inverse of negative? We don't take inverse of negative. We don't. That is if you do. Okay, so you have to understand what your calculator is trying to tell you. Okay, you have to understand what your calculator is trying to tell you. Your calculator doesn't know what you're trying to find out. Okay, we had this discussion before also. So for example, if let's say you take sine inverse of minus 0.5, what you get is minus 30 degrees. Okay, so if you take sine inverse of minus 0.5, you get minus 30 degrees. What your calculator is trying to tell you is, it's trying to tell you that there is a certain value, minus 30 degrees, where sine is 0.5. But the question is that the only value where sine is equal to minus 0.5? No. Okay, there are multiple other values as well. How do we find out those values? Using our understanding of the quadrants, alpha and theta. Like for example, if let's say x square is equals to 4, what is x equal to? If x square equals to 4, what are the values of x in this scenario? So basically, it's the same way we add 360 and put a negative sign. We don't, it depends. Add or subtract depends on whether you want the cycle after or the cycle before. Yes, whenever you're finding out alpha, remember, so standard rules are non-negotiable. The standard rules is when you're finding out alpha, you take the inverse of the positive value. Okay, standard rules come nahi chadenge. Okay, and when we're going in a clockwise direction, it's negative. When we're going in an anti-clockwise direction, it's positive. Why is that? No, this is a standard rule that we have set. Okay. Acha. My answer to my question. If let's say x square is equals to 4, what is x equal to? Plus minus 2. Okay, plus minus 2. Okay. But what if you use your calculator at this point? You use your calculator and you find out under root 4. Your calculator gives you what? Just 2. So what does that mean? Does that mean the calculator is wrong? No. What that means is the calculator doesn't know what we're trying to do. Okay, we're trying to find out a number which if we square, we get 4. And we know from prior knowledge that it's not just 2, it's actually plus minus 2. Okay, so this was just to elaborate on, somebody said that what happens if you take the inverse of the negative value. Okay, the calculator doesn't know what the context of the question is. We know the context of the question. Okay, one more question. Tan x is equal to, sir, can you, yeah, that's what I'm getting to, Nayan. I couldn't have done that immediately. We're getting there step by step. Okay, tan x is equals to 1. Okay, and the range of x is minus 360 to 360. Okay. Now, I'll give you guys 2 minutes to try and figure this out, try and solve this question without my help. 2 minutes each, I'll give you 3 minutes. If you're able to, that's brilliant. If not, then, well, I'm going to solve it anyway. I hope nobody used the graphing app to solve this. Yes, yeah? Okay. So we start by finding a we start by finding alpha. So for that we take tan inverse of 1. We get 45 degrees. Okay. So here's a suggestion. Suggestion is that if your range allows you to go maybe slightly beyond one cycle or on the negative side as well. Okay. In that case, draw 2 separate sets of quadrants. Okay. What do I mean by that? Make one set of quadrants to cover the range that is from 0 to minus 360, and then make another quadrant to cover the range that is from 0 to 360. Okay, so 0 to minus 360, and then from 0 to 360. Or you can say from minus 360 to 0, and then from 0 to 360. Okay. Now, is this the only way of doing it? No. I'm pretty sure that this is not what maybe some of you opted for. Okay. Maybe some of you opted for something else, and I'll tell you what that is. Okay, you guys can correct me if I'm wrong. So here's 0, here's minus 90, here's minus 180, here is minus 270, and here is minus 360. Okay, so that's taken care of, made 2 quadrants. Okay, that's great. And then here's 0, here's 90, here's 180, here is 270, here is 360. Okay. Alpha is 45, tan is positive. That means it's still going to be in the same quadrant. Okay, doesn't matter whether it's negative, positive, clockwise, anti-clockwise. The order of ASTC remains the same. Okay, so it's positive. No, wait a minute. Yeah, so it's going to be like this, and it's going to be like this. Okay. Is the first graph correct? Yeah, it's correct. Is there something wrong with it? Is there something wrong with it? Okay, so here we are going, wait, let me write down the value of alpha. 45 here, 45 here, 45 here, and 45 here. Okay, so this is, shouldn't the values move anti-clockwise? Clockwise, I mean. So remember, it's from minus 360 to 360. So I've drawn 0 to minus 360 separately and 0 to 360 separately. Okay, which is why here you see values moving in a clockwise direction because this is the negative range. And here you see the values moving in an anti-clockwise direction because this is the positive range. Take a closer look at it. You will find the answer to your question. All right, so this angle is going to be 180 minus 45. I know trigonometry is confusing, right? That's how it is. 180 minus 45, which is 135, but because we have measured it in a clockwise direction, we're going to write it with the minus sign. Okay? Don't let the minus sign freak you out. Okay? Or don't let the minus sign bother you with your solution. This in calculation is going to be 360 minus 45, which is 315. Minus 0 upon minus. Okay, I don't know what that means. Here, 0 upon 360. Yeah, so what about it? 360 minus 45 is going to be 315. It looked like off. Oh, okay. 0 off. Okay, yeah. I'm a little casual about my handwriting, yeah. So this is 315, but because we measured it in a clockwise direction, it's going to be with the minus sign. Okay? Acha, then for these values, things are pretty straightforward. 45 and 180 plus 45, which is 225. Okay, ab dekho. Another way of solving this question is that you can find out the values of one cycle. Okay, could be the one from 0 to 360, or could be the one from minus 360 to 0. Okay, so if let's say you found out the values of the first cycle, then you can find out the values of the cycle before that. How? Question for you guys. If let's say you first found out 45 and 225 and you want to find out the values in the previous cycle, what are you going to do? Very good. Previous cycle, I'm talking about previous cycle. You're going to subtract 360. So you could have done 360 minus 225. Sorry, 225 minus 360. And you could have also done 45 minus 360 to get the values of the previous cycle, okay? Or you could have done it the way that I've done it by drawing two separate sets of quadrants. Okay, so you have both the ways with you, both the methods are with you. I would suggest initially try out both the methods and then gradually decide which one makes the most sense to you. Okay, but your understanding should be there. Okay, do not set up any standard rule without running it through me. Okay, do not set up unnecessary standard rules for yourself, because if you do that right now and if they fit here, chances are maybe in the next couple of questions they will all come crashing down. How do you draw a vertical line for this question in the graph? So you make the graph of tan x and then you make a graph of y equals to 1 and you see what are the values of x where tan x is equals to 1. Acha, wait, vertical line. No, wait, that's a horizontal line. What do you mean by vertical line? Sir, when class ends? Why? Why all of a sudden do you want the class to end? It's going to end at 6, inshallah. Can we do minus 135 plus 360? Yeah, you could do that instead of 360. No, wait a minute. That's the same thing. Minus 135 plus 360 or 360 minus 135 is the same thing. It depends on... Acha, I would suggest you keep 360 as your benchmark only. Okay, whether you're going to add 360 or subtract 360. Otherwise, you'll end up confusing yourself. So now what we're going to do is we're going to do some range altering questions. Okay, so we're still solving trigonometric equations. Sir, but I did the homework smooth after class. I don't know why. That's probably because you understood the concept. Okay, so now we're going to do some range altering trigonometric equations. Okay. And as always, this will take a few examples to get the hang of. Okay. So I've taken out some questions. Let's do those. Yeah. Okay, so I want you guys to take a look at maybe the first question. It's cos 2x equals to 0.6. Okay. And tell me, what is different here? Yes. Exactly, 2x and x. So basically, here's what I want you guys to do. Okay, I'm now going to go back to Desmos. Okay. So here we have cos x, let's say from 0 to 360. So quick question for you guys. Let's see how well you remember this concept. And that is, from 0 to 360, if let's say we have to make cos 2x, what happens then? From 0 to 360, we have to make the graph of cos 2x. What happens then? Two cycles. Perfect. Okay. So from 0 to 360, pay close attention, okay? From 0 to 360, how many times will cos x be equal to 0.6? How many times? I'm not looking for the value. I'm just looking for the number of times cos x is equal to 0.6. You can see it in front of you. From 0 to 360, how many times is cos x equal to 0.6? 2. Perfect. Okay, if you can see it, here's once and here is the second time. Okay. If let's say instead this was cos 2x. Okay, I want you guys to think about my question first. If okay, you've answered it already. Okay, brilliant. So if let's say it was cos 2x instead of cos x, then how many times would you expect the graph to be equal to 0.6? 4. Good job. Okay. Now explain to me why you say that. You're right. All of you are right. 4 is the correct answer. Yes, because the graph will repeat twice. Okay, so if let's say I change this to cos 2x, now we're making 2 cycles. That means cos is passing through the same value, not twice, not twice, but 4 times. No, 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 please. Like I said, whatever standard rule you set up for yourself, please run it through me first and know that is a horrible standard rule, frankly. Okay. Okay, so let's try and solve this question. Okay, so let's keep that in mind and let's try and solve this question. Okay. So why did I call this the range altering question? Why did I call these questions the range altering trigonometric equation? So first of all, if you look at the range that you're given, this is x, but what's the angle used in the question? That's 2x. Okay, so here we have x, and the angle used in the question is 2x. Okay, so how do we fix this? There's got to be a way to fix it, right? Yes, we alter the range. Okay, because here we're solving for 2x and here we have x. So what we do is we alter the range. Okay, so let me solve one question from scratch and then you guys can ask as many questions as you like. 0 to 180. Okay, so in questions like these where the angle and the range that you're given is different. Sorry, I'm confused about what you just said. Okay, so here's what I said. Okay, if the range that you're given is of x, whereas the angle used in the question is slightly different than that, then what do? We alter the range. Okay, and we make sure that we have the range for the same angle that's used in the question. So what's the angle used in the question? It's 2x. What is the range that we have? It's x. So what we're going to do now is the first step, the prerequisite of solving this question is to alter the range. Okay, how do we do that? How do we bring x to be equal to 2x? What do? We multiply it by 2. Yes, this is some kind of horizontal stretch, but the thing is, the reason why we're not using those terms is because we haven't formally done transformation. When we do transformation, inshallah, after trigonometry, things will make a lot more sense to you in functions. Okay, which is why I always do trigonometry first and then transformation later. Okay. So 2x is now lesser than or equal to 360. X is greater than or equal to 0. So that means this is now your new, or you can say your altered range. And that's it. Okay, that's the only thing different that you're going to do in this question. Okay, so now what you're going to do is you will still find out alpha. Kaise? You will take cos inverse of 0.6. Let's do that. Let's take cos inverse of 0.6. Let's see, what do we get? We get 53.1. So cos is positive. Cos is positive. What does that mean? That means it could be in the first or the fourth quadrant. A, S, T, C. Our range is now from 0 to 360. So here's 0, here is 90, here is 180, here is 270, and here is 360. Okay. So here is 1 alpha, here's the second, 53.1, 53.1. Okay, but now bear in mind 53.1 and 306.9 is correct, but remember what you're solving for at the moment is not x, because what you're solving for technically is 2x. Okay, so that means now the solutions are going to be 2x equal to 53.1. Okay, and then the same 2x is equal to 180 minus 53.1, which means 306.9. Okay, and now remember, whenever you're asked to solve an equation, you always solve for x equals to, y equals to, never 2x equal to or 2y equals to. So that means you have to solve for x, and the way to do that is by dividing all the values by 2. Okay, so that means x is equals to, yes, Nayan, your answer was correct. X is equals to 26.1 and 161.6. These are our final answers. Easy? Yes, questions like these are easy. I'll tell you when things get really difficult. When you have to add or subtract something, that is when things get difficult. I mean, not difficult, you just have to be more attentive. Okay, we're going to use the same concept as I've used over here, but you just have to be more attentive. Okay? So this is how you solve questions like these. Okay, they're not that difficult. I'm going to do part B as well. Then I'll give you guys some questions to solve. Isn't second one 153.45? I don't know. I just read an answer and wrote it down. 306.9 divided by 2 is 153.5. Yeah. Okay. Sorry about that. So whoever said, well, whatever I wrote earlier, you might want to check you've done something wrong. Okay, thank you for pointing that out for us. Okay, let me do part B and then I'll give you guys some questions to solve. I don't know, I just 26.6 है, double check कर लेते हैं. 53.1 divided by 2 is 26.6. Yes. Khair, I think you probably made a typo, whoever said the answers earlier. 26.6 and 153.5. Yes. 270 plus. Okay, we're not going to do 270 plus 53.1. We're going to do 360 minus 53.1. Remember, it's the fourth quadrant. In the fourth quadrant, it's 360 minus alpha. Yeah. Okay. Let's do part B. Okay. Now, keep your eyes open for part B. Okay. So, part B, you have sine 3x, which is equal to 0.8. And the range that you have is for x from 0 to 180. What if we don't change range and do cos inverse of 0.6 and then divide by 2? Then how would you know what the other value is? How would you know what the other value is? If you don't change the range, then you might think that the range is still 180 and you might end up ignoring this value. You get what I'm saying? If you don't change the range, you might think that the range is still 180 and you might end up ignoring this value. Because here we're finding out the answers for 2x. And the reason why we went ahead with 306.9 is because this was inside of this range. Okay, does that answer your question? I hope it answers your question. If it doesn't, I'll come back to it. Okay, let me get through this. If it doesn't, I'll come back to it. So what if in the quadrants we make it like 0, 45, 90, 135, 180? What does that mean? What does that mean? You mean you number the quadrants like that? 0, 45, 90, 130. You can't do that. Is that a 45-degree angle or a 90-degree angle? It's still going to be a full circle. A full circle will still be a 360 degrees. You can't change a full circle to 180 degrees. समझ आ रही है बात? I mean, what is this angle going to be? It's going to be 90 degrees, right? Whether you do it clockwise or anti-clockwise, it has to be 90 degrees. So make sure you measure this as 90 degrees. You can't do this 1, 0, 45, 90. That doesn't make sense. कैसी बातें कर रहे हैं आप लोग यार? I think ज़्यादा math पढ़ ली that you started questioning the basics. ऐसे ही? Khair. Anyway, so first step is we alter the range. Okay. And how do we do that? We multiply everything by 3. So 0 remains 0. Okay. Please don't end up changing 0 to 3. Okay, I've seen people do that. And 180 times 3 is 540. Okay. Now, because this is 540, our new range allows us to go slightly beyond one complete cycle. Okay, when I say one complete cycle, that means 360. Our range allows us to go slightly beyond one complete cycle. Okay? Achha, how do we take that into consideration? If you change 0 to 3, then your answer wrong, plus you make the question harder for yourself. Actually, if you think about it, if you change 0 to 3, it's not going to have an impact on your final answer, but it's still stupid, right? So please don't do that. 3 cycles, okay, 3, not necessarily 3 cycles. Remember I said there is no correlation between the coefficient of x and the number of cycles. Okay, so you will get 3 cycles if the range was from 0 to 180. Okay, so you will basically get, let me solve this question, then we'll settle the debate of how many cycles. Okay, Otherwise, we'll just end up going on a completely different tangent. So we start finding out alpha, which means we'll take sine inverse of 0.8. So yeah. So sine inverse of 0.8, that's same as above. Acha, 53.1, okay. All right, now 53.1. Our range is from 0 to 0 to 540. So here 0, 90, 180, 270, 360. Okay. Here we have alpha. Now, you guys must have seen me doing all these steps. Okay. Now, the reason why I do them is not to add like aesthetic appeal to my solutions. The reason why I do it is because this decreases the chances of me getting a question wrong. So what I'm trying to say is this is additional working to make sure that your answer is correct. Okay. And I encourage you guys to do the same. Because if you do it directly and then if you complain that, oh, I'm not getting the right answer, I don't understand the concept, that's not true. You're just not putting in the right amount of effort. 53.1 and 53.1. Okay, acha, keep your eyes and ears open. So when we start solving this, here's one answer. So 3x is equals to 53.1. Okay. Yeah, go the extra mile for your own good, always. And then 180 minus 53.1, 180 minus 53.1, which is 126.9. Is that it? Is that it? No, why not? Yes, very good, because we have more range, okay? Our range doesn't stop at 126.9. Our new range allows us to go 540. And what will I do to get more solutions? What will I do in order to find out the value of the values in the next cycle? Plus 360. So add 360, what do you get? See if it's inside the range. 360 plus 53.1. Yep, 413.1. Still safe. 126.9 plus 360. Yep, still safe. 486.9. Okay. Now, even though we haven't crossed 540, but if you add 360 to 413.1, what happens is it's outside the range. Okay. So this is where we stop, but it's not the end of the question. We still have to find out the values of x. And Fawaz, I'm assuming your calculation is correct. I'm just going to write down these values straight away. 17.7, 42.3, 137.7, 162.3. And in the end, make sure that your values of 3x are inside the range of 3x, which they are, and make sure that your values of x are inside the range of x. And let me tell you something. If your values of 3x are inside the range of 3x, then it's inevitable that your values of x will also be inside the range of x. Mazaya? Sine 3x generally means 3 cycles. Okay, who said that? Who said sine 3x means 3 cycles? Remember, what did I say? I said there is no correlation between the coefficient of x and the number of cycles. The number of cycle depends on what? The number of cycle depends on what? Question for you. I mean, you're telling me the general form of a trigonometric equation. That's not what my question is. My question is the number of cycles. You know, you could have sine x and still have 3 cycles. That's also possible. Now you're probably questioning your concepts. Okay, yes, it depends on the range. Hey, ऐसा नहीं है that whatever the coefficient of x is, that will be the number of cycles. Okay, the number of cycle depends on the range that's given to you. Okay, so what do? You find out the new period. Okay, once you have the new period, then you look at the range, and that is how you decide what will be the number of cycles. See, this is what happens when you set up these standard rules for yourself, okay, which don't make sense. Here we have sine 3x. देखो मेरी बात सुनो. Sine 3x. So what is a sine bx plus c? What is b? B is... Wait, are you thinking that b is the number of cycles? Is that what you're thinking? Oh my god. B is not the number of cycles. ठीक है? B is the coefficient of x, which we use to find out the period, which we then use to find out the number of cycles that we will have to draw. Okay? अच्छा अब देखो. Remember I said that you could have sine x and still have 3 cycles. What is the range of x here? From 0 to 360. What if I change the range and I say that, you know what? Draw it till 1080. How many cycles do you see now? You see 1, 2, 3 cycles. So does that make sense that the coefficient of x decides the number of cycles? It does have a role to play, but it doesn't decide exactly the number of what the number of cycles will be. Okay, they're not exactly equal. Okay, you get what I'm saying? There is a role to play. There is a role coefficient of x will play, but it's not going to give you exactly the number of cycles that you need to draw. Okay. अच्छा अब देखो sine 2x, okay, but if I change the range from 0 to 180, in fact before I do that, if I change the range from 0 to 180, how many cycles are you going to expect? Think about it before you answer. If I change the range of x from 0 to 180 and you have to make sine 2x, how many cycles are you going to draw? Think about what I'm saying. Sine 2x, and I change the range from 0 to 180. How many cycles are you going to draw? The correct answer is 1. Okay. Why 1? So the thing is, if you do your working systematically, you won't have to worry about it. Okay. If you do your working systematically, you don't have to always get confused. ठीक है? देखो मेरी बात सुनो. Remember the formulas? Remember the formula sheet? अच्छा मैं अभी ज़रा थोड़ी देर में ये पढ़ूंगा कि आपने क्या लिखा है. First let me take out the formula sheet. Yeah, here it is. ठीक है? Now this is there for a reason. Okay, this is there so that you can refer to it and find the answer to your question. How do you determine the period? You determine the period by taking 360 if it's sine or cos and dividing it by b, which is the coefficient of x. Okay? Fawaz, are you with me? Okay, Fawaz, you're with me. Sorry, my question was for Faiz. Faiz, are you with me? Okay, so we're talking about graphs in particular. Okay? Sine 2x, and the range is from 0 to 180. Okay? Now, how are you going to calculate the new period? You're going to take 360, divide by 2, which is 180 degrees. ठीक है? अच्छा, अब आप एक सिंपल सा काम करें. आप देखें आपका एक साइकिल कितने डिग्रीज में ख़त्म होगा? 180 डिग्रीज में. और देखें कि आप ग्राफ बनाएंगे कहाँ तक? 180 डिग्रीज तक. ठीक है? Now can you tell me how many cycles you're going to draw? Yes. Yes, Shayan, you're right. Okay, I'll repeat. So, do you remember the formulas? Yes or no, Faiz? Be honest. You do? Sure. What is the natural period of sine? Okay, I'm assuming you meant 360. Yeah, okay. What is the natural period of cos? Okay, what do we mean by natural period? Yeah, very good. Okay. So here we have sine 2x. How do we find out the new period? You have the formula in front of you. The natural period divided by the coefficient of x. So that means now it will take 180 degrees for one cycle to complete. ठीक है? So far so good? Okay. Now, if it takes 180 degrees to complete one cycle, and you can only draw it till 180 degrees, okay? If you're only allowed to draw it till 180 degrees, how many cycles will you be able to make? Thank you. ठीक है? समझ आया? So it has to be done systematically. Don't set these stupid rules for yourself that if sine 2x, if it's 2, we make 2 cycles. Okay? That's not how it is. Because I know where the standard rule is coming from. In most cases, since the range is from 0 to 360, you inevitably end up drawing 2 cycles when it's sine 2x or cos 2x. But that's not because this is a standard rule. Okay? All good? Okay, so I am going to give you guys some questions to solve. I want you guys to do part C. So I'm not going to give you guys a lot of questions. I understand trigonometry can be mentally draining. So I want you guys to do part C, but I still have to make sure that you guys understand what we have done today. And the only way to prove that to me is by solving these questions correctly. So I want you guys to do part C, D, and F. Okay? Do these 3 questions. I am going to go grab some water. I will be back on my desk in 2 minutes. Arranged like C38 and 128, all right. Tero. 37.98, yes. So 38.0 and 128, that's correct. Good job. Okay, part D. Can I have the answer to part D? 105, 165. That is also correct. 105, 165. Okay. Part F. Can I have the answer to that? 111.6. Yeah, 116.6. So Bedula and Nayan. Tero, I'll just double check. Sine inverse 116.6. 116.6 and 153.5. Yeah. That's correct. Burned out, making silly mistakes. Okay, that's fine as long as the concept is there. Okay, so I think let's keep it till here only. I will give you guys some questions very similar to these questions only. Okay. Yeah, you can leave. Okay. No, we're not going to do something. Can you explain how you got 165? So, okay, I can do that. So if you guys want to leave, go ahead. Allah Hafiz, have a nice weekend. The rest of you guys can stay. So sine inverse of 0.5, that's going to give you 30. Okay. Now, because it's negative, that means it's in the third and the fourth quadrant. So in the third quadrant, it's going to be 180 plus 30. And then in the fourth quadrant, it's going to be 360 minus 30. So 360 minus 30 will give you 330. And when you divide 330 by 2, that is when you get 165. Okay, I don't know who asked that. Fahama, yes. That's how you get 165. Okay, so your initial values will be 210 and 330. Yeah, 210 and 330. And then when you divide those values by 2, you get 105 and 165. Okay, all good now? Okay, so I'll stop here. See you guys inshallah on Tuesday, like I said. Take care, everyone. Have a nice weekend, whatever is left of it. Allah Hafiz.